This is ionization and dissociation. Before we start defining each of these terms, let's look at this simulation. Okay, let's look at the molecular level. I mean micro. So if we dissolve sodium chloride in water, let's see what will happen. Look at that. It breaks apart into its chloride and ion and sodium cation. Okay, now let's reset. Let's dissolve sucrose. This one didn't break apart. Then the question we ask ourselves, what's the difference between these two compounds? What's the difference between them? So from what we did earlier, we know sodium chloride is ionic. It's an ionic compound. So sodium chloride, ionic compounds dissociate into its ions, cation and its anion. Non-ionic compounds do not dissociate. Look at that. Non-ionic compounds do not dissociate. Okay? And then these ionic compounds that dissociate, you see, they dissociate because of that they conduct electricity because of the presence of ions. You see that? Then non-ionic compounds, they do not dissociate. They're not good conductors of electricity because there are no ions. So let's classify the following as ionic or covalent compound. If we look at sodium chloride, methane, magnesium oxide, hydrochloric acid, we can classify as ionic or covalent. Pause the video and get your answers. Which ones are ionic? Which ones are covalent compound? So here we go. Remember, ionic compound is formed between metal and non-metal and involves transfer of electron, while covalent compounds are formed between sharing of electron between non-metals. So sodium chloride is ionic, carbon tetrahydride or methane, the common name is covalent. Magnesium oxide is ionic, hydrochloric acid is covalent. So from the simulation, we can see that ionic compounds dissociate. So what is dissociation? Dissociation is the separation of ions that occurs when a solid ionic compound dissolves, while non-ionic compounds do not dissociate in water. Okay? So when we write equations for showing the dissociation of ionic compound, there are two important things to notice about writing dissociation equations. Generally, do not include water as a reactant. Okay? It dissolves in water, and when it dissolves in water, it becomes aqueous. ion charges must be included because they separate into its ions. So this is the example of dissociation equations. So like we saw sodium chloride in water, we saw how it separates into its ions. And this has to be balanced. If you don't have experience in balancing it, you find out that these subscripts will form the coefficient here. Okay, so that's how it's balanced. And then you see this, it forms this coefficient. But if you have experience, you don't have to do that. You can easily balance it. So this is an example of equation of showing dissociation. Each of these form cation and anion. They separate. The water is not part of the reactant. Then I would like you to pause the video and try to do this. Write the dissociation equation for this. Hopefully, you got the answer. This is the way it's supposed to be. So you grade yourself. Did you get it right? Okay. Note, it must be balanced. It must be balanced. If it's not balanced, it's not correct. Again, you see this? 2 is the subscript here, and that forms the coefficient here. Here, there's sulfate. Remember, this is polyatomic ion. Okay, it's a unit. Then this one, you see these 3, it forms the coefficient here. That's how it's balanced. How do you know the charges here? Remember, we have periodic table for main group elements with charges. You can use that to figure that out. You don't have to memorize it. Then let's look at this one, this simulation. Okay. If we look here, this is acid, this is water. So in water, this acid will ionize. 100% ionization. Look at it. We can look at it another way. Look at this. This is the acid we started off, and now almost 100% of that goes to ionizes. Almost 100%. Look at, there's almost nothing remaining. It's 100% ionized. You see this arrow going to the right completely. Okay. So this is ionization. Ionization. It's not dissociation, it's ionization. So ionization is the process in which individual positive and negative ions are produced from a covalent compound that is dissolved in solution or in water. Remember, you went from acid in water, almost everything is 100% ionized. Okay. Remember that covalent compounds are held together by covalent bonding, while ionic compounds are held together by ionic bonding. So example is this. So like one, you see this one is ionization. This is ionization. You produce positive and negative ions, but here water is part of the reactant. This hydrogen combines with water to give hydronium ion. And the same thing happens here. Okay. So this is ionization. It's not dissociation, it's ionization. Covalent compounds or molecular compounds ionize. So Identify as ionization or dissociation and write a balanced equation for the following. Pause the video and write, identify as ionization and write a balanced equation. Identify as ionization or dissociation and write a balanced equation. Hopefully, you pause the video and you're supposed to get this. This is dissociation, this is dissociation, this is ionization, this is ionization. Here are the equations. Look, in dissociation, you see that water is not part of the reactant, while in ionization, water is part of the reactant. So that's it. I hope you get something out of this. Thank you.